Good morning, my dear students. Last class, we have discussed the differences between distance and displacement. Now, in this class, we can see different types of speeds. So, the first we have to know what is speed, and after that, we can know what is uniform speed. And after that, non-uniform speed, or another name for that is variable speed, average speed or mean speed, and next one is instantaneous speed. These types of speeds we are going to learn in this class. The first one is speed. So why should we define the speed? Means if an object is in motion, means its position changes with respect to time, it covers some distance in some particular interval of time. Then by how much time they are taking to cover the distance will measure how fast they are moving or how slow they are moving. For example, if we ask two boys to run on the ground, so one boy covers the same distance in less time and another boy covers the same distance taking more time. Means we say that one is moving faster than the other. One boy is running faster than the other. So we have to compare the distance with respect to time. That physical quantity we have named as speed. Let us consider that. So let us consider that a body covers a distance of s meters, covers a distance of s meters in time t seconds, in the time of t seconds. An object covers a body or a particle or an object we can consider. So a particle also we can consider. So let us consider that a particle covers a distance of s meters. Covers a distance of s meters in a time t seconds. Covers a distance of s meters in the time t seconds. So fine. Then consider that a man is going on a cycle and he covered 50 meters. He covered a distance of 50 meters in 10 seconds. A man is going on a bicycle. He covered 50 meters in 10 seconds. Then in 1 second, how much distance he covered we want to know. Then we will write it as 50 meters by 10. This gets cancelled. So in 1 second we will come to know that 5 meters is the distance covered. So in 1 second he covered 5 meters. Means in 2 seconds he can cover 10 meters, 3 seconds 15 meters. So distance traveled in 1 second we give a name. So that is called unit time. That is 1 means unit. 1 means unit. So and we are giving here unit time. In the unit time he covered 5 meters per second. So in unit time he covered 5 meters. So that is his speed. Means he can cover 5 meters in every 1 second. Now see my dear students, so here also in t seconds, here also in t seconds he covered s meters. In t seconds he covered s meters. Then in 1 second how much distance he covered I want to know. That is I am writing s by t in the similar manner. 10 pence cost 50 rupees. Then 1 pen cost is 5 rupees you will get. Means you should divide. So this 50 you should divide with the 10. So that is you are getting 5 meters per. So that is 5 meters you are getting. 10 pence cost 50 rupees. Then 1 pen cost is how much? 50 by 10. Similarly, t seconds he covered s meters. In 1 second, how much distance he covered we want to know. That is called s by t. So this is called 1 second means we have a special name that is called unit time. So this is called distance. This is called speed. So speed is equal to. So now from here we can write speed is equal to. So what will write my dear students? Speed is equal to distance by time. So we are writing the formula speed is equal to distance by time. So this is we have defined as a speed, distance traveled per unit time. See my dear students, now see the definition of a distance. And the formula of the speed also we know that. So formula also we know that. So that is called, what is that? V is equal to, so V is equal to, we have written S by T. If T is 1 second, if T is 1 second, that is unit time. If T is 1 unit, if the time is 1 unit, then we will get, S is equal to, okay, that is then if time is 1 unit, this value is 1, then S is equal to V. Then we get distance is equal to the speed. So distance traveled in unit time, distance traveled in unit time is called speed, you can define. So definition of speed is distance traveled, distance traveled per unit time. Distance traveled per unit time is defined as a speed. Unit distance traveled per unit time is called speed. Is called speed. So see my dear students, we know that unit time means 1 second. So we know the formula for speed also. Just now we have seen the formula. Speed is equal to distance by time you are writing. If the time is 1 second, then S by 1 is S. S is equal to V. If time is 1 unit, that is called 1 second. So if time is 1 second, then the distance becomes a speed. So we are defining speed as distance traveled per unit time is called speed of the object. Okay students, now we have seen what is speed. So we can see its units. So speed we are denoting with the letter V, and distance with the letter S, and time with the letter T. So now we are going to write SI unit. So SI unit of speed. SI unit of speed is SI unit of distance we will write. To get the SI units, we should write, to get the SI unit of speed, we should write the SI unit of distance and we have to write the SI unit of time. So SI unit of distance is meter. So meter, and SI unit of time is second. So you can write the meter symbol is the meter symbol in the SI table is M, and the second symbol in the SI table is S. So meters per second. So it is meters per second, you got the unit. Now, and this second power nothing is there means power 1 means you can write meter. So meter per second. So this is called meter second. So SI unit you got it as what is that? Meter by second. We read this as meter by second, meter by second, or you can write it as meters per second, meter per second, you can call meter per second, or if you take this second upward, it will become meter second power minus 1. Now next one is CGS unit. So CGS unit. So you are writing the CGS unit of speed. So to write the CGS unit of speed, we should write the CGS unit of distance. CGS unit of distance is centimeter, and the CGS unit of time is second. So it will become centi symbol C, meter symbol M. So centimeter, and the second symbol is S. So centimeters by second, or we can write that is centimeter by second, or centimeter second power minus 1, or the same you can call centimeter per second, or the same thing you can read like this also, centimeter second inverse, that is second power minus 1, second inverse. These are the SI units and CGS unit of speed. Okay students, already we have seen what is the speed, and see my dear students, speed is measured with a device called speedometer. That speedometer is there in the front of the bikes or cars. We have the speedometer, and by seeing that speedometer we can say what is the instantaneous speed at that particular instant of time. So speed is measured with a device called speedometer, and that speedometer measures the instantaneous speed. So now we can see what is uniform speed. So now the second definition we are going to learn, that is uniform speed. So uniform speed. See, I am going to take a table for this explaining the uniform speed, and later we can see the remaining things clearly. So to describe this uniform speed, I am taking time t in seconds, time t in seconds, time t in seconds, and distance s in meters I am taking. Distance s in meters I am taking. Time t in seconds and the distance in meters I am taking. Now see, so consider that a man is going on a cycle. A man is going on a cycle. At 0 seconds, he covered 0 meters. After 1 second, he covered 4 meters. 1 second, 4 meters. 2 seconds, he covered 8 meters. 3 seconds, he covered 12 meters. 3 seconds, 12 meters. And similarly, 4 seconds, after 4 seconds, he covered 16 meters. A man is going on a bicycle, 0 seconds, 0 meters. After 1 second, 4 meters. 2 seconds, 8 meters. 3 seconds, 12 meters. 4 seconds, 16 meters. 5 seconds, he covered 20 meters. So like the distances he covered when he is going on a bike. So that is when he is going on a cycle. Okay students, so I have taken a small table here, time in seconds, distance in meters I have taken. Okay, now he is covering the distances as given in the table as follows. Now see my dear students, so for every 1 second, see the interval of time from here to here, the interval of time is 1 second. The covering distance is 4 meters. And from here to here you see my dear students, again 1 second, he covered 4 meters. 0 to 1, first second. In the first second, he traveled 4 meters. So next, after 1 second, 4 meters. After 2 seconds, 8 meters. Means in the second, in this interval of time, again 1 second is the difference time. 4 meters he covered. Here also 1 second, and the covering distance is 4 meters. Next 1 second, 4 meters. Next 1 second, 4 meters, and so on. He is covering, means he is covering equal distances in equal intervals of time. So we say here, the C students, the key word for uniform speed is, the important key word for uniform speed is equal distances. Equal distances in equal intervals of time. He is covering equal distances in equal intervals of time. However, the however the small intervals may be. So if an object covers equal distances in equal intervals of time, equal distances is covering in equal intervals of time, however the short intervals of time, the small interval of time, 1 second I have taken here, 1 second he covered 4 meters, next 1 second 4 meters, next 1 second 4 meters, every 1 second he is covering 4 meters. So he is covering equal distances in equal intervals of time, then he is said to be moving with uniform speed. So then he is said to be moving with uniform speed. So that is the definition of uniform speed. And remember, my dear students, uniform speed means speed is constant. In the brackets also you can write it. Uniform speed means speed is constant. So uniform speed means speed is constant. So speed remains constant throughout the journey. So speed is constant in the given time interval. The given time interval. So then we say that the object is said to move with uniform speed. See my dear students, what is uniform speed? The definition we have seen, and uniform speed means, so this uniform speed means, you can also say that constant speed. You can also say that constant speed in the given interval of time. So see, for this given table, I want to find the speed. So 0 to 5 seconds covered distance is 20 meters. So I want to find the speed. Speed is equal to distance, so distance 20 meters. So I am writing the distance is, so we are writing here distance is 20 meters and the time is 5 seconds. 20 meters in 5 seconds. So you can write 20 meters by 5 seconds. Then 20 fours are 5 fours are, so we will get 4 meters by second, or we can write that 4 meters per second, or we will write that 4 meters second power minus 1. Or you see, my dear students, after 2 seconds you check it, what is the speed? 2 seconds 8 meters. So then again write it 8 by 2. So 8 meters in 2 seconds. So 8 meters in 2 seconds you are writing. Then cut with 2. Then you will get 4 meter second power minus 1. Or after 3 seconds you check it. 12 by 3, 4 meters per second. After 2 seconds you check it, 4 meters per second. Means every time the speed is constant. So uniform speed means it is said to be moving with a constant speed. Speed is constant. So after 5 seconds, 20 meters we have written. Then the 20 by 5, you are getting 4 meters per second. After 2 seconds, 8 meters, 8 by 2, you are getting 4 meters per second. After 1 second, 4 meters, you are getting 4 meters per second. So every time speed is same only. If we give the more time, he covers more distance, less interval of time you give, he covers less distance. See, 5 meters, 5 seconds, 20 meters. Like if I give the time of 10 seconds, can you say what's the value, children? So see, 5 seconds 20, then 10 seconds he covers 40 meters. So speed, uniform speed means constant speed, you can also say, and we know the definition is covering equal distances in equal intervals of time. However, the short intervals of time or small intervals of time. So speed is constant, we are writing. So from the table also we have seen that speed is constant. So speed is constant means we are writing speed is equal to, so what we write, students? Distance by time, that is equal to, and that is equal to, so that is equal to constant we are writing. So distance by time is equal to constant we are writing. Means we can write distance, means we can write distance is directly proportional to the time. This constant, if you remove it, so distance is proportional, distance is proportional to time. So distance is proportional to time. So we are writing like this, distance is proportional to the time you are writing. S is directly proportional to t. This proportionality symbol, so we will write like this. So distance is proportional to time. So means more time we give it, more is the time we will give it. So more distance we covers, less time we give, this time value less time we give, less distance we will cover, but the ratio of distance by time is constant, and that is constant means speed is constant. Speed is constant in the given interval of time, then we use the word uniform speed. Uniform speed means constant speed. So S is directly proportional to T means, see students, 0 seconds 0 meters, 1 second 4 meters, 2 seconds 8 meters, 3 seconds 12 meters. Like more time, more distance, but every time the distance by time ratio remains constant. And if we plot a graph also, and if we draw a graph for that, see students, so indirectly you are getting S is directly proportional to time we have written, S is directly proportional to T we have written. So S is directly proportional to T we have written, my dear students. Now the next thing is, see what is the next thing. So I will take I am taking distance in meters and I am taking time in seconds. So distance in meters and time in seconds I am taking. Time on the x-axis, distance on the y-axis. Okay, now see students, this is 0, 0 second, 1 second, 2 seconds, so 3 seconds, 4 seconds, 5 seconds, 6 seconds, and here we have, consider 4 meters, so 1 second, 0 seconds, 0, so 0 seconds, 0, 4, 8, 4, 8, 12, 16, we can write it. So 1 second 4 meters, 1 second 4 meters, 2 seconds 8 meters, So 2 seconds 8 meters, the graph will be like this. Means if the object is moving with uniform speed, then the distance time graph. So distance we are taking in meters, time we are taking in seconds, then the distance time graph is a straight line. So we are getting the distance time graph is a straight line inclined to this time axis. So this time axis we can also consider this is the x axis, and we can also consider here so y axis. So the distance time graph is a straight line inclined to x axis, making some angle with time. Okay students, this is about uniform speed.